Hello students, now this is the first lecture in vector calculus. I'll let you know what we will discuss in this chapter or what we have already discussed about vector space. For that, we have read in the earlier class that this world is divided into two types of physical quantities. One is called scalar quantities and others are called vector quantities. What are scalar quantities? Scalar quantities are those physical quantities which has got magnitude only. That is, for example, mass is a scalar quantity, speed is a scalar quantity, etc. Other quantities are vector quantities, those physical quantities which have got both magnitude and direction. Example for that is velocity, acceleration, weight, momentum, etc. Now, when we have the idea of these two types of physical quantities, the scalar physical quantities we have discussed in the vector, the differential calculus discussed in first year. Uh, all those functions which we have discussed in the uh, BSc, BA BSc first year were scalar functions. We had found their domain, we have found their relation, we have found their limit and their continuity and differentiability, we have integrated them, etc. Now in this book of vector calculus, we will again do the same. We'll find limit, we find continuity, find differentiability, we will integrate them, etc. for only vector point functions. So before we go to the main topic, let us discuss what we have read about vectors in our previous class. In the previous class, we have we know how to add vectors, we know how to multiply vectors, and we know how to multiply a vector by some scalars. There are only three operations in vector calculus. As in algebra, there were four operations: addition, subtraction, multiplication, and division. So we don't have any operation. We can't, if you divide a vector by another vector, you know that it is meaningless. So division by another vector is not possible. Again, if you want to subtract two vectors, we'll multiply second vector by negative scalar and add them. So therefore, we have only three operations. One is we can add vectors. Second is we can multiply vectors. Third is we can multiply any vector by some scalar. So there are three operations only. There is no fourth operation. So in four operations, before we go to the main topic, so how will we add these vectors? How will we add these vectors? We will add these vectors by, we have two laws. One is triangle law of addition of vectors, and the other is paragon law of vector addition. How will we multiply them? So we have two types of products. One is dot product, other is cross product. Okay. And third is, if we multiply some scalar by any vector by some scalar, means we are magnifying or we are reducing the size of that vector. Okay. Now let's have some summary of the dot and cross product. So whatever we are discussing in this book, we are discussing in three dimension. So let's discuss dot product of two vectors. So for the discussion of dot product two vectors, let us consider two vectors, vector A and vector B, in space, and let theta is the angle between them. Therefore, their dot product is given by A dot B is equal to magnitude of A vector into magnitude of B vector into cos of theta, which is the angle between the rather acute angle between the both vectors. And this can also be done as in simple way. Magnitude of A vector is written by A and magnitude B is written by A in order to save time. So dot product of A dot B, dot product of A and B vector is written as AB cos theta. If we see its geometrical interpretation, if you want to see its geometrical interpretation, we'll find that AB cos theta means magnitude of the first vector into the component of the second vector in the direction of first vector, or A dot B is the magnitude of second vector into component of first vector in the direction of second. So by this, when you find the dot product of two vectors, we will always get a scalar quantity. That is, if we find the dot product of any number of vectors, we will always get a scalar quantity. Now let's go to the vector or cos product of two vectors. For that, let us consider two vectors in three-dimensional space, vector A and vector B, and let theta is the angle between them. Let n unit vector n be the vector which is perpendicular to both vector A and vector B, such that they form a right-handed system. It is important if the n vector A vector B vector does not form a right-handed system, means we can't find their cross product. So here we are assuming that A vector, B vector, and n vector form a right-handed system. Therefore, their cross product is given by magnitude of A vector into magnitude of B vector, sine of angle theta angle between them into vector n, which is perpendicular to the both A vector and B vector. Important note here is vector product of two vectors is always a vector quantity whose magnitude is equal to the modulus of their cross product, or that is AB sine theta. Theta is angle between both vector, which is acute angle, and direction is perpendicular to both vectors. Now, if we generalize this cross product, we find that if we multiply two or more than or any number of vectors, their cross product is always a vector quantity. So we read the previous class about the dot and cross product of two vectors. Now in this class, we will proceed towards finding of the cross and dot product of three vectors. For that, let us consider three vectors: A vector, B vector, C vector in the three-dimensional space. If we keep vector A, vector B, vector C in the same alphabetical order and introduce dot and cross product between them, then we have the following products. You also know that if you want to find the cross and dot product of two vectors, we must have only vectors. So for finding the triple product with dot and cross product, we have these four possibilities: A dot B cross C. Second is A dot B dot C. Third is A cross B dot C. Fourth is A cross B cross C. Now let's conclude that which of these products, triple product is meaningful or which is meaningless, and why? A dot B dot C is meaningless. Why? Because when you find dot product A and B, this is scalar quantity, and if you want to find the dot product of two vectors, both the vector must be vectors. Therefore, you can't find the dot product of a scalar quantity and a vector. That's why this product is meaningless. Similarly, A dot B cross C is meaningless. Why? Because A dot B is a scalar quantity. You can't find the cross product of a scalar quantity and a vector. Third is A cross B dot C. A cross B is a vector. Again, you can find C is also vector. We can find the this triple product. This triple product is a scalar quantity, and what it means A cross B is a vector, and vector into vector is a scalar. So this is a scalar quantity. Therefore, scalar quantity, and it involves three vectors: vector A, vector B. So this is called scalar. Certainty scalar. It involves three vectors, so scalar triple product. And fourth is A cross B cross C is again meaningful because A cross B is a vector which is perpendicular to A cross B. So resultant vector of A cross B vector into C vector is again a vector. Cross product of vector is a vector quantity. So therefore this is meaningful. So resultant of these three vectors is a vector quantity. It involves how many vectors? Three. So this is called vector triple product. You always keep in mind that while doing any calculation in mathematics, you must use word mass. Word mass, B means bracket, O means of means ka, D means division means bhag, M means multiplication means guna, A means addition means jama karna, S subtraction means घटाना. The formula for remember this is B for bracket means कोष्ठ, ब्रैकेट बोलते कोष्ठ. सबसे पहले खोलो कोष्ठ, फिर खोलो का, तकसीम गुणा को हल करके जमा नफी को हाथ लगा. So this is very easy to remember, and always while doing any calculation mathematics you must follow this formula of word mass. Now let's define scalar triple product. Scalar triple product of three vectors, vector A, vector B, and vector C, is defined by A vector cross B vector dot C vector, and is denoted by vector A, comma vector B, comma vector C within big brackets, or vector A, vector B, vector C within big brackets. Therefore, the scalar triple product of three vector ABC is written as A vector comma B vector C vector within bracket is equal to A vector B vector C vector within big brackets is equal to A vector cross B vector dot C vector. So it is called scalar triple product because it involves three vectors and find result in the scalar quantity. So now let's discuss the geometrical interpretation of this scalar triple product. So if we find the scalar product, what will be the resultant? So for that, we'll prove this article. Prove that the scalar triple product of three vectors is equal to the volume of the parallelepiped formed by the three vectors originating from the same point. This is a basic condition. Originating from the same point means they must have a conterminous edge or common edge. Then and only then you can find the scalar triple product of three vectors. This is a very important condition. So for the proof of that, Let's consider a parallelepiped having conterminous or common edges OA, OA, OC, and OG, such that vector OA is equal to A vector, vector OC is equal to B vector, OG is equal to C vector as shown in the diagram. Let n be the unit vector perpendicular to both the plane of vector A and vector B, and phi is the angle between vector C and unit vector n, which is perpendicular to both vector A and vector B. As shown the diagram, from G, draw a perpendicular GL to the plane of vector A and vector B such that GL is equal to P, which is the height of the parallelepiped. Now, let's discuss this in conclusion. So, by the definition of scalar product, we write vector A, comma vector B, vector C within big vector is equal to A vector cross B vector dot C vector. Now, let us find vector A cross vector B vector, vector A cross vector B vector. So, vector A cross vector is equal to, by definition of cross product, vector A magnitude sin theta into vector n, unit vector n, which is perpendicular to the plane of vector B and vector C, and theta is the angle between, theta is the rather acute angle between vector A and vector B, right? So this is again equal to vector A into B sin theta into vector n. B sin theta, if you consider triangle OHC, OSC, OC, it is right angle at H, OHC right angle at H, so it's a right angle triangle. In a right angle triangle, this is CH upon OC is equal to T ratios is equal to sin theta. Therefore, CH is equal to OC is equal to B or magnitude B vector is equal to B is equal to OC sin theta, OC sin theta, or this OC sin theta is equal to CH. CH is the CH is now CH is the CH is B sin theta. OA is the base of this parallelogram, and CH the height. So OA and CH will give you the area of this parallelogram OA CH base into height. So this is equal to, this implies cross product of two A and B vector is equal to area of the parallelogram OABC, and you are left with the vector and this magnitude of this cross product, and direction will be perpendicular to both vectors. Now, if you substitute its value in the previous equation, the resulted will be area of the parallelogram OABC into n into C. You substitute value of A cross B. This comes out to this. Now n dot C, again we'll find the dot product of n dot C by definition of dot product, magnitude n vector, magnitude of C vector into cos of phi. Phi is the angle between, acute angle between vector n and unit vector n and C vector. So this is equal to magnitude of unit vector n is equal to 1. So now this C is equal to C cos phi. C cos phi, if you go to the main diagram and we consider this is right angle triangle C cos phi. See, this is base, this is hypotenuse. C cos phi means this will give you GL. GL upon C cos phi, GL upon GO is equal to cos of phi, base upon hypotenuse. Therefore, GL is equal to C cos phi, C or the CL cos phi is equal to C cos phi is equal to GL. Now, substituting the value in the dot product C and N in the scalar triple product, we got scalar triple product of ABC is equal to area of the parallelogram OABC into GL. What is GL? GL is the height of the parallelepiped. So area of a parallelogram, base parallelogram OABC into P height, this will give the volume of the parallelepiped with conterminous edges, vector A, vector B, and vector C. Important note here is scalar triple product represents the volume of parallelepiped whose conterminous edges form a right-handed system. Thank you.